Hey there, students. Ever wondered why air gets hotter when it's compressed? That's what adiabatic heating is all about. Let's break it down. First off, adiabatic might sound fancy, but it just means no heat is exchanged between the forces outside and the forces inside a system. Imagine you have a piston and you start compressing air inside a cylinder. As you push the piston down, the volume decreases. But something else happens too. The air temperature rises. Why? Well, when you compress the air, you're doing work on it. That energy has to go somewhere, right? In an adiabatic process, this energy increases the internal energy of the gas, which means the air molecules start moving faster. Faster moving molecules equals sign higher temperature. Let's get a bit more formal. According to the first law of thermodynamics, energy in a system is conserved. In an adiabatic process, the work done on the gas equals the change in its internal energy. Since no heat is lost or gained from the surroundings, all the work done on the gas goes into increasing its internal energy, which raises the temperature. You might be thinking, where do I see this in real life? Great question. Adiabatic heating happens in a lot of places, for example in bike pumps. When you pump air into a tire, the air gets compressed and heats up. Another example is in meteorology. Ned Nikoloff has created an interesting theory on global warming that posits that adiabatic process provide more than 90% of our global warming. When air descends from higher altitudes in the atmosphere, it compresses and warms up, which can affect weather patterns. Conversely, as air ascends, it decompresses and cools down. This is why Big Bear is always cooler than the surrounding desert areas. So now, to the atmosphere. Solar flares create increased pressure on the Earth's surface. Scientists have learned that within 5 days of a solar flare, there is excessive heat waves on Earth. An interesting article at this nature.com site. Adiabatic heating explained in simple terms. Compress air, temperature rises, and it's all about energy conservation. Easy, right? Thanks for watching and stay curious.